Hello, I'm StVsSpassky, a physicist. So, special relativity theory, brief and simple. Its core is an experimental fact: the light speed invariance. Let us explain. Here are two wave patterns from the vibrator on the surface of the water, at rest, and when moving at a speed of v. The first pattern is symmetrical, the wave velocity is the same in the directions, equal to c. The second pattern is obviously asymmetric, because of the constant displacement of the vibrator to the right. An observer, connected with a moving vibrator, should notice the asymmetry of the pattern, the different speed of the waves in the directions. And suddenly, he sees symmetrical circles with a speed of c at any movement. This is a paradoxical invariance of c. Historically, from the 18th century, physicists have understood the wave nature of light. But in 1881 Michelson, in his experiment, suddenly revealed a paradoxical light speed invariance. Physicists were in shock. Then, in coordinate system, that is actually resting relative to the wave medium, a rather simple and symmetric wave equation works. Only in these systems. But in 1904, Lorentz, for his studies of light, found that this wave equation also works in moving coordinate system, but only if distortions are introduced into such system. Say imagine that the wave has moved further behind, because we see it there, at a later moment of so-called local time, and in front, at an earlier moment of this time. Here are the Lorentz transformations. That is, Lorentz found how to reorganize the second asymmetric pattern to the first one, symmetrical, as if the vibrator is resting relative to the wave medium. Or, how to go into a moving system and still preserve the C invariant. And a year later, in 1905, Einstein in the special relativity, developed one idea of the mathematician Poincaré, the idea of the possibility of constructing a satisfactory theory purely formally, mathematically, only on the basis of the postulate of the invariant C. And Einstein found with what distortions the moving system should be visible, so that the speed of light waves in any direction would be equal to c in this moving inertial system, as well as in the resting one. These are three distortions, fix them: time dilation, longitudinal length contraction, and the time phase at the back is ahead of the time phase at the front. It turned out, the transition into a distorted system in special theory totally coincided with the Lorentz transformations. And since then, special theory has been using them. In fact, this is a transition from pattern 2 to pattern 1. It would be possible to realize that Lorentz and Einstein were essentially solving the same problem. That the complete coincidence of the transformations in transitions of special relativity with the Lorentz transformations for waves clearly suggested that the objects of our world are wave objects on a wave medium. Einstein then rejected both the wave medium itself, so-called ether, and common sense in physics in general, either according to young maximalism or under the influence of Mach's ideas, or failing to explain the phenomenon of the invariance C. This was the beginning of the gap between classical physics and modern. Note that now in the presentation of the special relativity, they always somehow forget that later, in the general theory of relativity, Einstein returned to primordial medium. Was it possible even then to explain the invariant phenomenon? In principle, we can assume that subjects and objects around us are made up of atoms, which are wave objects, and are distorted when moving. When moving a group of objects together, at approximately the same speed, they're all distorted equally, and atoms, and objects, and subjects. For this reason, subjects are not able to reveal the general distortions of the system. They perceive everything in it as undistorted, as in systems resting relative to the wave medium. This means that they will also perceive the speed of light same in the directions. But objects and systems, moving relative to them, will be perceived as distorted. Then it turns out that all systems become equal in status. And the subjects of any system are not able to understand which of the systems really rest relative to the wave medium, that is ether. We have explained the C invariant phenomenon. Now let's turn to the wave objects themselves. In systems resting relative to the wave medium, there are basically two types of wave objects, a traveling wave and a standing wave. Note exactly, as number of types of microparticles. A traveling wave always moves with speed c. We consider it as an analog of particles without rest mass, such as a photon. A standing wave is a dance of wave at one place, in a certain limited space. You could see its analog in a cup of coffee. A standing wave can be represented by a set of looped waves all directions, and synchronous. In a standing wave, the dance zones are separated by so-called zero spheres. From the viewpoint of mathematics, it is possible to consider that the wave is reflected from such sphere as between two walls. A standing wave can also move, but only with speeds less than c. We consider it as an analog of particles with a rest mass. Inside it all looped waves are interconnected, so it is enough for us to consider only one of these looped waves, the others will have the same parameters. Now consider the distortions themselves in the special relativity theory. First distortion: slowing of oscillations. Here is an object of type standing wave at rest relative to the wave medium and when moving, say, along the x-axis. Consider only the transverse looped wave in both cases. This wave is shown in object at rest and inclined one in moving object with speed v. The slope should be so that in the system of the object the direction of wave motion looks transverse. In the moving object the cycle time is longer according to the ratio of the lengths of the inclined trajectory and transverse one. This slowdown should be the same for all looped waves. And the oscillations of the whole object, as well as the passage of time in it, will become slowed down. Now look at the ratio of hypotenuse and vertical leg. This expression is called the Lorentz factor and is denoted by gamma. It manifests itself in all three distortions. Second distortion: longitudinal length contraction. At rest, the time of the transverse and longitudinal cycles is the same. Hence, in a moving object, the cycle time of the inclined wave and the cycle time of the wave in the longitudinal direction must remain the same. Relative to a moving object, the longitudinal wave velocities are forward c minus v, backward c plus v. From the comparison of cycles, it can be seen that their equality is achieved only at the longitudinal reduction of the size of the moving wave object by Lorentz factor. Third distortion: the advance of the time phase behind. At rest, a transverse wave intersects the x-axis at the same time by its front. And the oscillations throughout the object are synchronous. But in the moving object, the inclined wave does not cross the x-axis at the same time. There is the advance of the time phase behind. And the oscillations in the object are no longer synchronous. While the inclined wave runs at the speed c, along the x-axis a certain wave of the phase passes through the object at a speed greater than c. This is the so-called de Broglie wave. To compensate this distortion, the dependence of time on the x-coordinate is introduced in the Lorentz transformation. So, a moving rocket is shortened on length, the clock in it is slower and the clock has the advance of the time phase behind. Mass-energy equivalence. For a fragment of an electromagnetic traveling wave, there is the relation obtained long ago, still by Maxwell. E is the energy, p is the momentum of the wave. For an inclined wave, it can be seen that the vector E0 receives a horizontal vector addition, and in length, that is in magnitude, E0 is increased by a factor of Lorentz. This also applies to the rest of the looped waves. This means that the energy of the entire object is increased by the factor of Lorentz. So, in a moving object we have the factor of Lorentz at low speeds is slightly larger than 1. There is an invariable part of E0 and a small addition to it in motion. This is what we call the kinetic energy. Equating, we see that the energy E0 of our object at rest through the usual inertia parameter m should be. For an inclined wave, this relation is obvious, where px is the component of the momentum along x of this wave. For the whole object, this leads to the well-known relation. So, when moving, the energy of an object is, and its momentum, as you can see from the picture, is. I want to emphasize that this approach does not contradict the usual presentation of special relativity theory, but only is an version within the framework of sense for students. You can look at my other videos on the subject. If you like this video, point it to others, because this subject on the internet is heavily littered. Thanks for attention.